We live in a digital world now, and participating in the digital economy is an imperative for all. These videos are designed to help you quickly understand the key digital topics and the technologies in approximately 5 minutes. A number of 2017 industry analyst reports indicated that many organizations are not really progressing fast enough with leveraging digital technologies for business value. McKinsey and Company indicated that less than 40% of organizations are digitized. Dynatrace, in a survey of over 1,200 organizations, found 48% of survey participants indicated digital performance challenges were hindering their success in their digital transformation. A 2017 OECD study for the G20 meeting on the key issues for digital transformation indicated that 50% of organizations experience one or more of the challenges we shall shortly present, slowing down their participation in the digital economy. A review of industry reports and studies, as you can see here, from leading analysts and digital leaders, comes up with a pretty consistent list of the top challenges that limit or slow digital transformation. We shall take a look at these now. Lack of a clear vision and strategic intent relating to leveraging digital for business value is a limiting factor in setting the direction and focus for the organization. Lack of knowledge and competence that gives leaders the confidence to set the right vision and plan, and for other stakeholders the ability to productively contribute in the transformation. Attitudes towards existing systems and technology presents a barrier to new technology adoption, whether it be sunk cost or emotional investment, or perceived technical challenges such as integration and interoperability. Performance management and return on investment visibility is an issue, where organizations are not experiencing the impact of their technology investment. Lack of focus on the customer and their digital engagement and journey in the acquisition of your organization's products and services, another important issue that slows down digital transformation. Inertia at all levels. At the highest level, the perception of risk that significant change to the business or business model might bring, right down to the operational level where fear of the unknown and what might be the consequences of digital transformation for the individual or teams. Digital transformation can enable and require culture change. Digital has the potential to change how individuals live and work. The term SMART is often used as a catch-all prefix to communicate a status or initiatives related to the application of new technologies to produce innovative, advanced and valuable solutions for the benefit of specific stakeholders and society in general. The term SMART is usually associated with the Internet of Things, where more and more of the physical world are connected. In this slide, we are looking at what is driving the smart Internet of Things. Society is the driver for smart, but how do we define society? Society is an aggregate of people living together in a more or less ordered community of common purpose. The society could be global society, or a segment that is global in nature, or it can be local, or a segment that is local in nature. So it can be broad or narrow in purpose. For the purpose of our exploration, we are discussing society in general in a geographic region. So citizens, consumers, government, public service, providers of goods and services. When we consider society, in effect, it is a group of resources available in the environment. Society is generally concerned with how well those resources are utilised or converted to meet the needs of the members of the society. Society is often measured by how well it manages its resources and the stakeholders' experience of living in that society. Most society have aims that include sharing, fairness and equity, meeting the members' needs, and of course improving the members' lot over time, if we refer to Maslow's hierarchy of needs. Smart initiatives across society are about achieving those aims through leveraging technology, such as smart agriculture, smart industry, smart energy, smart health, smart mobility, which includes smart transport, smart space, smart learning, smart leisure. Smart Internet of Things has become a reality for many societies due to advances in science, technology and engineering, making it economically viable for the application of new technologies. Some key contributors to these advances include, for example, miniaturization has been enabled by progress in material science and engineering, allowing sophisticated properties to be included in both materials and very small devices, thus removing previous physical barriers. Wireless broadband and its performance is no longer a limiting factor in connecting devices to each other and to the internet, so data connectivity barriers have been removed. Cloud technologies coupled with data analytics and machine learning tools allow for processing of large complex real-time data and data sets from billions of connected devices. Data processing barriers have hence been removed. We use the term device to describe any connected physical thing regardless of function or sophistication. Each connected device will normally have the following features: embedded electronics, software, network connectivity, and a unique identifier, making it interoperable with other devices and the internet. The deployment of these devices could bring the following benefits: efficiency, accuracy, real-time, remote, operation hazardous conditions, and complex situation control. We consider devices in three categories. At the simplest level, we may be talking about sensors, for example, temperature, speed, switching, or an actuator responsible for moving or controlling movement, such as a switch, relay, or valve. The next category includes more sophisticated devices. They may be subsystems providing subfunctions with multiple components and component subfunctions in their makeup. These could include an engine, a gearbox, a robot, a control unit, which are all part of a bigger system. This increased sophistication leads to more data and data types, enhancing what is known at any point in time and what can be done at any point in time. At the highest level, we have the main system or ecosystem we are applying smart management to, such as an airplane through its life, a metropolitan area, a building, an assembly line, where the system is made up of many device types connected and integrated. We'll now look at a few examples. Our first review, we will look at smart leisure. Technology, when applied to a golf course where sensors such as moisture level, grass color, temperatures, coupled with weather data sources and a local controller device to determine where, when and how much irrigation is required to keep the course in good playable condition. Only dry patches on the course get irrigated when required. This smart management of space and resources minimises the cost of maintenance and wasteful use of water, but it leads to a positive experience for the player during the game. More sophisticated players will use mobile devices to guide improvement in their game, maintaining statistics on performance of their shots automatically, and often this information is shareable and used in cloud-based applications in golfing communities. Now let us look at smart agriculture. Society wants to get high quality food at cheap prices, and the farmer wants to get maximum productivity and income from his farm. Both want this in a way that is environmentally friendly. One example is using sensors on livestock which monitor their location, their activity, their health, feeding, and their output, such as milk yield. The farmer uses this data to plan and manage the husbandry of the livestock and compliance with the regulations. The consumer benefits from smart application of technology in agriculture by having confidence in the food chain from source to plate, cost and quality. This occurs when there is an integration and connectivity between the systems of the supply chain participants and the government for tracking. More sophisticated farmers may use satellite data for planning tillage of land and GPS for autonomous working vehicles on the land. Our next example is smart cities or metropolitan areas, and a subset such as smart transportation, one of the fastest growing sectors in IoT. Local government want to create vibrant, successful societies in their cities, and one key component is for citizens to be able to travel around their city effectively, efficiently, safely, and comfortably. Sophisticated traffic monitoring and control using sensors such as audio, video, social media monitoring, and mobile device tracking are all used to keep traffic flows, whether it be pedestrian, cycle, car, or public transportation, moving while dealing with the blockages. Equally important is citizen real-time information on travel in the city, so they can make choices on the means of travel and the routes and the timings. The citizen's experience of travel is more positive. The economic cost of mobility for citizens and society is reduced, as is the environmental impact of transportation by deploying Internet of Things, smart devices in a coordinated manner in our smart cities. Thanks for your attention. I hope you found this video useful and informative. Below you can see other videos in the digital series. If you need any further information, you can go to the listed websites, or you can email me at info@intelligentorg.com. Thank you again.